Hello and welcome to my channel. This is a series of problems where we solve one problem every day. So today we'll be discussing a problem in complex analysis. Please visit this link for more problems. This has previous problem as well with the solution. The link is also given in the description of the video. So let's head to the problem. So let gz be an analytic function in a neighborhood of z0, and suppose that gz0 equals to 0. Then we need to prove that gz by z minus z0 extends to an analytic function at z equals to z0. So let us first try to understand the problem. So the first thing is that what is an analytic function? Okay, so analytic function means that f is said to be analytic we also call it holomorphic in a region U if f is differentiable at every point of U. Okay, so this is analytic in a region. Now what is analytic at a point? So when I say that f is analytic at a point z equals to z0, it means that there exists a neighborhood of z0 such that f is analytic in that neighborhood. Okay, so this is the definition of analytic function. Now it's asking us to prove that this gz by z minus z0 extends to an analytic function at z equals to z0. So it means I have to define a function. So it means that I have to define a function fz whose value at z equals to z0 we have to determine, and if z0 equals to z0, then this is nothing but gz by z minus z0. And the final function f has to be analytic at z equals to z0, that is, it is analytic in a neighborhood of z equals to z0. Okay, so let's see how to define, or let's think of how to define. So before heading to the solution, I suggest to pause the video and try it at your own. Okay, so I hope you tried this problem and hopefully get a solution. The solution that I'll be provided may not be unique. There could be different solutions. So if you have a different solution, kindly comment it. Okay. So GJ, so what would be, so first of all, we need to make a guess that what should be the value at Z0. So see, in order to a function to be analytic, first of all, it has to be continuous. So what if f is continuous at z equals to z0, then what is the value at z0? So see that we need to determine what is the limit of this at z equals to z0. Okay. So it's like if I see that, note that what is the value of this if I take z tends to z0. And what is this? This is nothing but 0. So this is same as this thing is same as this. And what is this? This is nothing but g prime z0. So it suggests that I should take g prime z0 so that the function has to be continuous first of all. Okay. Yeah. Okay. So let's try with this and see whether f is analytic or not. Okay. So given that the function g is analytic in a neighborhood of z0, We consider the following function gz by z naught, z minus z naught if z is not equals to z naught, and g prime z naught if z equals to z naught. So what do we need to say? We need to prove whether this is analytic at z naught. That is, whether it is analytic in a neighborhood of z naught. Okay. So we'll be using a famous theorem in complex analysis, which is called the Riemann removable singularity theorem. Okay. So this theorem talks about the analytic extension of a function. Okay. So if U is an open subset of C and Z naught is in U, and let F be an analytic function on the deleted neighborhood, that is U minus Z naught, then F has an analytic extension over Z naught if and only if it is continuously extendable over Z naught. So it is enough to give a continuous extension of F at Z naught. So then from the Riemann's removable singularity theorem, we can conclude that this continuous extension is also an analytic extension. Okay. So as we have already seen that the extension is continuous, but let's formalize that. In order to prove that the function fz is analytic at z naught, we need to check if it is continuous at z equals to z naught. So note that limit fz, z tends to z naught, limit z tends to z naught, gz by z naught. This thing we have to prove that what is the limit this. Okay, this limit should exist. Okay. So what? So I can write this limit at gz minus gz naught because this value is 0. So I can write this as gz minus gz naught by z minus z naught. What is this? As we have already seen, this is g prime z naught, and this is the value of f at z naught. Okay. So this limit value is same as f of z. Okay. And therefore f is continuous at z naught, and hence using the Riemann's removable singularity theorem, f is analytic extension of gz by z minus z naught at z equals to z naught. Okay, so this is general advice that whenever you have to uh, see whether the function has an analytic extension, first try to see what would be uh, a continuous extension, and then apply the Riemann's removable singularity theorem in order to uh, prove that the extension is analytic. Okay, so I hope you enjoyed this video. Okay, and thank you for your time and patience. We'll meet again for a new problem tomorrow. Goodbye, take care.